This lab we're looking at how to do axial symmetric parts. So we'll be looking at using the revolution feature. We'll also learn how to create work planes and how to use the hole feature to create some complex holes, like some countersink holes and things. Okay, let's delete that, sorry. Alright, here we go, let's get started. So at first we see we have a complex part, lots of complex features. Remember, we want to start out as simple as possible, start out with the main shape, and then we'll start adding details from there. Okay, so notice looking at this part, we can see that it's actually symmetric, meaning if I created this hatched profile here and then revolved it around the center line, I'd have the part. But let's notice one more thing. On this hatched cross-section here, the top half is the same as the bottom half, meaning it's symmetric about this horizontal line. So let's take advantage of that and let's just draw this top half here, and then we'll use the mirror feature to create the bottom half so that we save as much time as possible and save us from making mistakes. Okay, so let's create a new part. Make sure you're in a millimeter template here under the metric tab. Alright, so I want to create a sketch, and you can select any of these planes to work on. I'll select this plane. Okay, the first thing I want to do is make two center lines. The first center line, I'll make a vertical one. This vertical center line will be the line that I revolve about. And then I'll make another horizontal center line, and this will be the one that I draw the profile around that I want to revolve. Okay, so let's turn the center line off and just briefly sketch the rough shape of it. Let's not worry about the dimensions right now. This is a great thing about a parametric modeling software, is that you can get the shape before you get the details. So let's get in and let's just roughly get the sketch. Okay, make sure that's vertical. Now notice, if you come off at an angle, if you finally make it close to horizontal, you see this horizontal constraint icon pop up, and we want that for this one. Now this line, we don't want to make it vertical or horizontal. So let's come down here and just briefly draw. There you go. So we've drawn that. Now from this shape is going to be the same on the bottom side of this line here. So let's just mirror what I've drawn to the bottom side. So I can drag here to select what I've just drawn, click on the mirror, and now I want to select the mirror line. So click here to select the mirror line, and I want to mirror around this horizontal center line, and click apply, and there it is. I'm done. I could finish this sketch, then I could, let's just rotate this around, there you go, then I could revolve. Now when I revolve, I want to select the profiles I want to revolve. I want to revolve this profile and this one, and now I need to select the axis of which to revolve around, and that would be this vertical axis here. Alright, and there's our part. Now make sure we save it if I haven't already, or if you haven't done that already. I'm already in lab 3 here, that's nice, and let's call this demo 2. Okay. Alright, so I've saved this part. Easy enough here, so that was pretty quick to be able to get the overall form. Now let's go in and add the details of the dimensions. And I can do that by editing the sketch, which I used to make the revolution. Okay. So let's come back here. You can see the basic dimensions here. So I'm going to go through and add in those dimensions. Before I do that, let me show you the reason why I used a center line. Notice in these dimensions, this 20 dimension is between the left side of this hole and the right side of it. Okay, so this is giving you the diameter of that hole, since this part is actually symmetric. Alright, now why I use the center line, let me show you that. Let's click on dimension here, And now let's dimension between this line and go select the center line. If you click there, and now I can make it 20. Notice what it does is it dimensions to where the other side of this hole will be when you revolve it. So that's really nice. That's basically the only difference between a center line and a construction line. So if this line was a construction line, not a center line, notice that now the hashings or the dashes are different. Now if I dimension between here and a construction line, it doesn't go to the other side, it just goes to the construction line. So that's the only difference between a center line and a construction line. So let's make ours center line again. Let's go through and add in that dimension. And you can continue adding in the other dimensions here. So I won't need to explain this. I would recommend you pause the video, try to fully constrain the sketch by the dimensions that are given in the drawing, and then check back with me here in a minute. Alright, so let's add in these others. Let's add in this 40. Let's dimension between this point and this center line. Make that 40. Let's go between this point and the center line and make that 50. I can go between here and here and make that one 120. Between here and here is 8. Okay, notice since this part is or the top half of the profile was mirrored to make the bottom half, if I click and drag on this line here, notice the bottom section moves as well. That's an advantage of using the mirror, is that it makes the top part symmetric to the bottom part. Alright, we also want to add that to be 8. I want to add this angle dimension. Just click on this line and a vertical line there. Oh, not 8. 18. Now notice the one thing I haven't done, let's make that 60. Okay, now all the lines are blue, meaning it's fully constrained. If I try to click and drag any of these lines, I can't do it. Remember, you always want your sketch to be fully constrained by the time you make a feature with it. Alright, so now my part updated with added dimensions. So I'm pretty much done with this first part here. Now let's go in and add some of the details to it. Okay, the first thing I want to add in are these countersink holes here, and this information basically describes what that hole is like. Now if you refer to the slides in the lectures, in the lecture slides for the part modeling, I have some slides towards the end of that PowerPoint describing different types of holes, and it'll show you these different symbols and different specifications that are used to describe these holes. So you can refer to that to see what these symbols and dimensions mean. So I'll briefly describe them here and show you how to create it. Alright, this first line, the M4 X.76H, that describes the threads and some about the hole itself. The M says it's a metric hole. The 4 says the diameter of the hole, so between here and here, kind of small to see. That diameter is going to be 4 millimeters. This 0.7 is the pitch. That means the threads, whether they're coarse or fine threads. Okay. Now this symbol says it's a countersink hole. What countersink means, let's zoom in here. That means you have these angles here, kind of like a funnel at the top of that hole there. Okay, so that means it's a countersink hole, and the diameter of the countersink at the top is 8 millimeters, and this would be the countersink angle here. The 4X says there's 4 holes, 1, 2, 3, 4, and this symbol represents the depth. How far does the hole go down? So from here to here, it's 10 millimeters. Alright, let's go through and make this. Notice that all of these are on a circular pattern here that has a radius of 15. Okay, let's go back. So I'm going to use this whole feature to create the holes. So when I make a sketch, I don't need to make a circle and extrude. All I need to do is make a point that will tell me where that hole, basically where I will put the hole. So So let's make a sketch on this surface. And all I want to do with this sketch is create one point here. Now let's add a dimension for that point. Let's make that point 15 there. Okay, so now I've defined where this point is. Easy enough. I can finish that sketch, and now click on the whole feature, and now this whole dialog box is where I can add that information. This says it's a countersink hole. This top diameter, that's 8. 90 degrees is correct. The depth is 10 and the diameter is 4, so I can add all this in. Now yours may not have this depth, so it might be default to through all. What that would mean, if this termination is through all, meaning that that hole goes through everything in the part, as you can see with the preview. Okay, so there's no end to the hole, it keeps going. So you can change that just by selecting the termination to set it as a specific distance, and that's what we want is 10. Okay, now I can click this button here on the tap to make threads on the hole. Now the thread type, the M back here, this M says it's a metric hole. So instead of ANSI, Unified, which is the American standard, I can make it a metric profile here. And notice the designation is already on the M4 by 0.7, so we're okay there. Click OK, and I've got that hole. Easy enough. Okay. Now I can show you that hole. You can kind of view a cross section if you click on View, select this drop down arrow, half section. And let's select a plane to cut, and let's look at this one. Now you can zoom in and see what that hole looks like there. There you go, that's nice. Alright, click the red X, I don't want to keep that view. Okay, now let's simply pattern this hole to make the others. So I can click on circular pattern. I want to pattern the hole, the rotational axis. I can do this in any of these cylinders that has a vertical axis. I can select. This one's fine. And I want 4 holes there. Alright, easy enough. Okay, now the last thing I need to do is go through and add in these holes here on the outer edge. And it's a hole with a radius of 5 millimeters. And so let's go through and add in this one hole, and then I'll pattern it to make these others, and then mirror it to the other side to make the second row. Okay. Alright. Now, typically what you do when you make a hole is you start a sketch on a flat surface, and then either make a circle or select a point, or create a point and make the hole. The problem is the surface I want to sketch on is a curved surface. So notice if I click on create a 2D sketch, it won't let me select this curved surface here. I can't do it. Alright, if I select that curved surface and click create a sketch, it doesn't work. Okay, you can only create a sketch on a planar surface. So what I want to do is create a work plane, so a plane that is tangent to this curved surface here. There's lots of ways you can create work planes. The way we want to do it in this case, the easiest way is with the tangent to surface and parallel to plane. Alright, so I want to create a plane that's parallel to this one, but tangent to the surface up here, and there you go. You see this plane that I've made is tangent to that curved surface. Alright, now I can select this plane since it's flat, create a sketch on that plane. Let's rotate it around where I'm looking at that. Alright, and now I can create my sketch on here. Okay, so first let's go create a center line that goes right through the middle of this. Okay, turn the center line off, and now let's make one hole. It's a diameter of 10, and I can add this dimension of 40. Okay, and finish the sketch. So there's one circle. Now I want to extrude that circle as a cut. So let's click on extrusion. I can click on the cut here. Now, how far do I want to go? I could do it a certain distance. Okay, you don't want to go through all, because then you can see that would cut through the hub as well. The best way to do this, my design intent is that I only cut this thickness here. So what I can do under the extent is, I want to say extrude to, and let's just select this inside surface, and now the hole only goes from where I started it to that inside surface. I'll click OK. So there's one hole. That was easy. It was easy with the work plane. Now let's turn the visibility of my work plane off. That does not delete the work plane, it just makes it invisible. And now I can make the other holes. So let's go look here. I think there's 12 holes all around. So let's pattern this hole around the center axis. Let's make 12 of them. Okay. And now I want to make the other row. I can do that using a pattern. So I want to pattern the first hole and the other ones. If I hold shift, I can also select the circular pattern. Now select a mirror plane, not this plane, not that one. There you go, that plane there goes, cuts through the middle, and there's the preview. There it is. So we finished this part. The last thing you could do, or you need to do here, you could do this at the beginning, it doesn't matter, is make sure you update all your iProperties as specified in the lab document here. This is just documenting the part. Create a title to it, some appropriate title. What, lab 3, exercise 2. You can make sure, so go ahead and do this, guys. Add in the author, manager, company as specified in the lab. Under the physical tab, you can select what it's going to be made out of. We can say it'll be made out of aluminum 6061, and when we do that, notice here's the weight of it, about 0.7 kilograms. All right. So in this lab, we've learned how to make work planes. We've learned how to use the revolution to feature. We've learned how to use the hole feature. And hopefully that was helpful to you. So good luck on the other parts in the lab.